Hi everyone, my name is Herman. In this video, I will briefly introduce our work on text-to-audio synthesis. This is a joint work with many researchers at Amazon, done during my internship working with Wenbo Zhao and Gunnar Sigurdsson. In this paper, we explore training the text-to-audio synthesis system without using any text-audio pairs. We propose to learn the desired text-audio correspondence by leveraging the image modality as a bridge. First, the text-image correspondence is handled by a pre-trained clip embedding. Second, we learn the image-audio correspondence with videos. Such system has two benefits. First, we don't need any text-audio pairs for training the model. Second, we can scale up to larger video datasets. Now here's how the CLIPSynth model works. First, we have the synthesis model, which is a conditional diffusion model that generates male spectrograms. Second, we have the query encoder, which is based on a pre-trained clip model. The diffusion model is conditioned on the clip image embedding during training. Since the clip model offers a shared embedding space for image and language, at test time, we can instead feed some text query to the model to achieve text-to-audio synthesis. So here we apply a zero-shot modality transfer to switch from image queries used during training to text queries used during inference. In this work, we examine the proposed model on two video datasets. One is the music dataset that contains full-length music instrument playing videos. The other is the VGG sound dataset that contains 10-second YouTube videos covering diverse sound categories. Now, demo time. First, let me show some text-to-audio results on music. Next, here are some text-to-audio results on VGG sound. Now, here are some image-to-audio results on VGG sound. So please check out our demo website for more audio samples. Please check out our paper for more results for objective evaluation and subjective listening test. Finally, I want to talk about some limitations and future work. First, we noticed that many off-screen sounds occur in videos, which increases the zero-shot modality transfer gap. Second, the system cannot handle purely audio-specific queries such as loud, quiet, high-pitched, or low-pitched because they have little meaning in the visual domain. For future work, we are interested in enabling combinatory prompts such as piano plus guitar. We also want to scale up the system to larger video datasets. To sum up, we propose a new text-to-audio synthesis model that can be trained using only on-label videos. Please check out our paper for more details and results. Thank you.